The square root method is one of four ways that we can use to solve a quadratic equation, but it's really only applicable if we have a quantity squared on one side and a constant on the other. So when we have a quadratic equation that's set up in this particular way, we can isolate the x or solve for x by taking the square root of both sides. Now, anytime we take the square root of both sides of an equation, when that radical wasn't initially part of the equation, when we introduce it like this, we have to consider both the plus and the minus possibilities. And one way that we can do that is to place that plus minus on the constant side. So let's play this forward a couple of steps and see what happens. The square root of a quantity squared, these two operators are inverses of each other and they're going to cancel each other out, right? The square root of 2 squared is the square root of 4, which is just going to be 2. So when we see a radical over a quantity squared, we can think about those things as canceling each other. So on the left-hand side, we end up with just x, and on the right-hand side, we have plus or minus the square root of 36, which is 6. And what this means is that we actually have two solutions. X is equal to 6, x is equal to negative 6. And let's plug these two solutions back into the original equation to check our answers. So the original equation was x squared is equal to 36, so we'll open up that x variable hole to enable us to plug our solutions in. And first we'll plug in x is equal to 6 and we can see, yeah, 6 squared is 36, so that answer does work. But let's notice that if we plug negative 6 into that variable hole as well, the negative will also be squared, giving us positive 36. So this answer also works. We get two solutions, both the plus and the minus 6, which is why we need to consider that plus minus when we originally take the square root of both sides. So let's take another look at this example. In this case, we could either go ahead and take the square root of both sides to begin with, or we could divide off that 25 to begin with. But since 25 doesn't divide evenly into 54, and I would end up with fractions over there on the right-hand side, I'm actually going to leave that 25 right where it is because it does have a square root. This one won't be quite as clean as the last one, but we can still take the square root of both sides and use that square root method. When we take the square root of both sides, it does come along with a plus minus, and we put that plus minus on the constant side, not the side with the variable. Let's recall that if we have two things multiplied together underneath a radical, we can split that radical into the product of two radicals. If we have two things divided underneath a radical, similarly, we can split a radical over division. However, if we have two things that are added or subtracted under a radical, this radical will not split. We cannot split a radical over add or subtract. So back over here in our problem, we see that we have two things multiplied together under the radical over here on the left, which means that we can split that into the product of two radicals, square root 25 and square root x squared. We still have that plus minus on the right-hand side, and in order to simplify the square root of 54, we're going to break 54 into the product of two factors, and we're looking for the largest factor that we can think of that has a square root, and in this case, that would be 9. So on the left-hand side, let's go ahead and say that the square root of 25 is 5, the square root of x squared is x, and let's do the same thing on the right-hand side where we're actually splitting that radical up because we have the square root of 9 times the square root of 6 on the inside, and we can split a radical over multiply. Left-hand side is now just 5x, right-hand side is now 3 times the square root of 6 because the square root of 9 is 3. And in order to solve for x, we'll simply divide both sides by 5 to get that x is equal to plus or minus 3 rad 6s over 5. And this is actually two solutions to that quadratic equation. One of the solutions is positive, and then the other is negative.